converting between moles and molecules. What's important to understand is that 1 mole contains 6.022 times 10 to the 23rd molecules. This could also be in reference to atoms as well. It just means particles. So this gives us two potential conversion factors. We could do 6.022 times 10 to the 23rd molecules over 1 mole, or 1 mole over 6.022 times 10 to the 23rd molecules, really depending on what units we're trying to cancel. Putting Avogadro's number into your calculator, I apologize, I've dropped a 2 here. Add back another 2. Putting Avogadro's number into your calculator does need to be done a specific way because we're using scientific notation. You have a little button that has a weird little double E looking thing on it. It's most calculators right above the 7, especially if you're using a graphing calculator. So you do need to use that. If you try to use times 10 to the caret button, or you put times 10 in there at all, it's going to throw off your decimal place. So a simple example to start with, if we want to know how many molecules are contained in 3 moles of water. So our starting amount is 3 moles. We want to choose a conversion factor with moles in the bottom. So my 1 mole, and I'm going to put 6.022 times 10 to the 23rd molecules on top. I don't like to abbreviate this mole because it's confusing, but it's kind of okay to put molec. Just try to make it a little bit shorter on yourself. So what you're typing into your calculator is 3 times 6.022, little e, 23. If you're not typing times 10 to the, that's not how that function works. You'll know you did this correctly if you get something that rounds to 1.8 times 10 to the 24 molecules. What this is going to look like on your calculator, you're going to see the 1.8, you're going to see a bunch of other numbers. At the end of this, you're going to see a little e and a 24. That little e24 right there means times 10 to the 24th. So that's how you actually read this in your calculator. So we can do more complicated problems pretty easily using dimensional analysis again. If we want to calculate how many molecules there are in 32 grams of iron fluoride, I've already gone and calculated my gram per mass for iron fluoride, which is 112.8402 grams per mole. So rather than kind of go and worry about writing out all my conversion factors, I'm just going to jump right into this bad boy. My starting amount is my 32.0 grams. Just keep in mind what I want to end up with over here is I want to end up in molecules. So that's my ending unit. So the first thing I need to do is I need to get rid of grams. Now, one thing that you do, one thing that you do need to keep in mind is that you can't go directly from grams to molecules. You have to pass through moles. So we're going to need to first use our gram formula mass, which is a gram-mole conversion. So as I told you up above, we have a gram formula mass of 112.8402 grams per mole. So now I've crossed out my grams, and I have moles on top. My next factor, I'm going to put moles on the bottom, and now I'm able to equate this to my number of molecules. So what you're punching into your calculator is going to be 32 times 6.022 times 10 to the 23rd. So remember using that little E button. And then you're dividing that by 112.8402. What this should give you is 1.71 times 10 to the 23 molecules. How many grams are there in 4.90 times 10 to the 25th molecules? So in this problem, we're starting with molecules, we need to end up in grams. We're still going to have to go through moles. I'm going to jump right down here and get started on this. 4.90 times 10 to the 25 molecules. Put that. For H2, my gram formula mass for H2 is just 2 times the mass on the periodic table for hydrogen, which gives me 2.01588 grams per mole. So first thing I need to do is get molecules in the bottom. I'm going to use 6.022 times 10 to the 23rd molecules, and that's equivalent to 1 mole. Now that allows me to get my molecules out of here. Keep in mind, I want my answer to come out in grams. So I don't have grams quite yet. I'm going to use my GFM to convert. So I've got 1 mole in the bottom, and on top I'm going to put 2.01588 grams, a gram formula mass for hydrogen. So you're punching in 4.90 E25 times 2.01588. I would punch it in one step and then do divided by, it'll pull up your answer, 6.022 E23 in your second step. And what you should get for this is a simple 64 grams. Go ahead and pause the video and try these 2 questions. I'll put the work up in just a moment. So for number 1, you're starting with 4.39 grams. Your gram formula mass for lithium chloride is going to allow you to cancel those grams. That gram formula mass is 42.394 grams. 1 mole on top. My grams are gone. And then I want to get a mole on the bottom, so I'm able to cancel my moles. My moles now will go away. Once you multiply by the top, divided by the bottom, should have something that rounds to 6.24 times 10 to the 22 molecules. Remember that times 10 to the 22 is just coming out as E22 at the end of your number on the calculator. The next one, we're starting with molecules and going into grams. 4.70 times 10 to the 23rd molecules. Our first conversion factor should get rid of molecules for us, so we're going to put them on the bottom. That's how many molecules are in 1 mole. So now our molecules are gone. Now we need to turn this into grams. My gram formula mass for silver nitrate I've calculated as 169.873. I need my moles in the bottom. I'm going to put my mole down here, and my associated grams are going to go right on top. So my moles have now gone away. So I'm multiplying across the top, and I would kind of do this in 2 steps, or you might want to put the 6.022 E23 in parentheses so you don't get any PEMDAS errors there. And what you get should round nicely to 133 grams. So we're going to have 3 sig figs. That's what we started with.